This story is about a tiny molecule that has changed the world of farming completely. Urea. In 1828, the German chemist Friedrich Wöhler obtained urea by treating silver isocyanate with ammonium chloride. This represented the first time that an organic compound was artificially synthesized without the involvement of living organisms. For this discovery, Wöhler is considered by many to be the father of organic chemistry. BASF was the first company to produce urea on an industrial scale in 1922. However, corrosion of the steel equipment hampered the move to larger scale production. It was the Dutch DSM researcher Scheef van Waas who discovered that by adding a little oxygen to the ammonia-carbon dioxide mixture, the problem of corrosion was largely solved. This passivation procedure was patented in 1954. Hence, DSM's licensing arm, Stamy Carbon, established its name in the urea industry. Today, at around 170 million tons per year, urea is one of the world's most produced chemicals. Around 90% of the world's urea is used to fertilize soil for agriculture, and more than 1/3 of all food grown in the world is grown from soil fertilized by urea. Global demand for urea is growing at an average of more than 3%, higher even than the rise in global population. The available arable land, however, has not grown since 1960, yet the average crop yields per hectare have increased greatly. In fact, the average cereal yield per hectare in Europe has tripled since 1960, in large part thanks to fertilizers like urea. Furthermore, the growth of non-food applications for urea has also boomed in recent years. Non-food applications include cattle feed, NOx reduction, urea resins, melamine production, and cosmetics.
Stamy Carbon is the global market leader in the development and licensing of urea technology. With more than 50% market share, we deliver technologies and services to all of our customers worldwide.
One activity is the licensing of new urea plants, providing the urea producer with knowledge and resources to build a reliable, state-of-the-art, low-cost and profitable urea plant that requires minimal staff to operate. Another activity is revamping or debottlenecking existing plants, along with improving efficiency and reliability.
Stamy Carbon was established in 1947 as the licensing subsidiary of DSM. In 2009, the company was acquired by Maire Tecnimont, which is an engineering, main contracting and technology licensing group.
Maire Tecnimont operates worldwide in the oil and gas, chemicals, fertilizers, petrochemicals, power, renewable energy and infrastructure sectors.
The group has 5 different companies. Of course, one of them is Stamy Carbon. The other 4 are Tecnimont, Tecnimont KT, Tecnimont Civil Construction, and Met New Energy.
Headquartered in Milan, Italy, Maire Tecnimont has over 50 operating companies in more than 30 countries and employs some 5,300 employees.
Stamy Carbon is the licensing and IP center of Maire Tecnimont Group. In 2010, we established the Maire Tecnimont Innovation Center, which is responsible for the innovation within all the different companies of the group and steers the research and development in these companies.
Stamy Carbon's main office is in Sittard, the Netherlands. The company also has offices in China and Russia and uses representatives and the sales offices of the Maire Tecnimont Group. The company has more than 65 years of licensing experience and has licensed various technologies to more than 1,000 companies in about 80 countries worldwide. Stamy Carbon has licensed over 250 urea plants located in more than 50 countries and has completed over 90 revamp projects in both Stamy Carbon and non-Stamy Carbon plants.
Whereas in the 1950s, plants could be for capacities as small as 50 tons per day, these days plants are typically built for capacities in the range of 3,000 to 4,000 tons per day.
All projects entail customized solutions, with the choice of several licensing models and EPC supply scopes, meeting the diverse requirements of our customers.
I think that if you ask for one particular distinguishing feature that we have in our company in comparison with our competitors, then it would be the commitment that we have towards full life cycle support.
Full life cycle support covers an array of services, including plant operation support, plant troubleshooting and optimization, studies and execution of revamp and debottlenecking projects, equipment inspections, and plant staff training.
Reliable equipment is very important for successful urea production, and Jfcltoday's expertise in design, engineering and the manufacturing of high pressure equipment in the field of urea production has led to the development of Jfcltoday stainless steel. This Jfcltoday stainless steel is developed dedicatedly for the use in high pressure synthesis sections in urea plants.
Since Jfcltoday's formation, innovation has always been part of the company's DNA. Jfcltoday has been a constant frontrunner with a series of innovations, most notable of which are CO2 stripping technology, Urea 2000 Plus technology, Avancore technology, fluid bed granulation technology, and Jfcltoday stainless steel. Many innovations take place in close collaboration with Jfcltoday's customers, suppliers, and contractors.
It's not that we do these innovations all by our own. We work closely together in our innovation efforts with suppliers, EPC contractors, and our customers as well.
The CO2 stripping technology, developed in the 1960s, was a major breakthrough in urea technology, almost halving the energy consumption of urea plants. The next major innovation was the development of the Urea 2000 Plus technology, featuring a pool condenser or pool reactor as a centerpiece. Pool condensation entails superior heat transfer and easier condensation, taking place inside the same equipment, where further reaction to urea happens. Urea 2000 Plus limits the number and sizing of high-pressure equipment and piping used in the synthesis section of a urea plant, simplifying both the design and construction and leading to a considerably lower investment. In cases where a Urea 2000 Plus plant features a pool condenser, the total plant height is reduced to a mere 42 meters. In 1994, the first pool condenser was successfully commissioned at the Jfcltoday plant in Bangladesh. Where a Urea 2000 Plus plant features a pool reactor, the condenser and reactor are combined in one single vessel. This is achieved by enlarging the horizontal condenser to create additional reactor volume, achieving sufficiently high residence times and eliminating the need for a separate vertical reactor. This way, the total plant height is decreased to a mere 30 meters. In 1998, the first pool reactor was successfully commissioned at the former DSM plant, now owned and operated by OCI Nitrogen in Geleen, the Netherlands. Jfcltoday's latest development in urea technologies is the Avancore technology. That comprises all the benefits of the Urea 2000 Plus technology, Jfcltoday, and experiences gained from revamp projects around a low elevation layout of the synthesis section and a reduced pressure inert washing system. For large capacities, the Avancore process features a pool reactor with a vertical high-pressure reactor based on ground level. For urea plants up to medium capacities, the Avancore process is also available, featuring a pool reactor only. The Avancore process reduces the required plant height to a mere 25 meters, obviously bringing down investment costs considerably. The Avancore technology was first licensed to Tierra del Fuego Energía y Química in Rio Grande, Argentina in 2010. Today, many plants are designed for capacities of almost 4,000 tons per day. Larger capacities remain interesting for their economy of scale benefit. All Jfcltoday synthesis technologies have been validated for 6,000 metric tons per day, and all equipment can be made available for this capacity.
However, there are some customers who still would like to see the equipment sizing, particularly the high-pressure equipment sizing, to be minimized, or also the number of this equipment to be minimized. For diverse reasons, you could, for instance, think of the geographic location of the plant to be built, giving cost to that, or also simply because of the customer needing a minimum high-pressure equipment associated cost.
In these cases, Stamicarbon's mega technology also allows for production capacities of up to 6,000 metric tons per day to be achieved in a single line, while keeping the sizing of the required high-pressure equipment and lines no bigger than the size for a 4,000 metric tons per day plant. The mega technology has been proven in a number of debottlenecking projects already. It can be used in combination with the Avancore or with 2000 plus technology. From the early 1960s, Stamicarbon was involved in the development of better materials to resist corrosion, which has always been a major problem in urea synthesis. Stamicarbon and the Swedish Sandvik Materials Technology jointly developed Safarex, a special duplex steel grade that is corrosion resistant at a low oxygen intake and resistant to stress corrosion cracking. Furthermore, it has a good weldability and superior mechanical strength. Safarex allows for drastically reduced oxygen intake, lower investment, and virtually maintenance-free static equipment.
Today, the most commonly used finishing technology in urea plants is fluid bed granulation technology, and Stamicarbon has a fluid bed granulation technology of its own.
The key success of the Stamicarbon fluid bed granulation technology is the urea film spraying nozzle. This technology requires the lowest possible use of urea formaldehyde solution and allows for unbeaten, uninterrupted runtime, hence enabling great operational cost saving. The technology also delivers a superior product that complies with all required quality and environmental standards. Prilling is another finishing technology widely used. The urea melt is prilled with the aid of a rotating prilling bucket. The urea melt droplets fall down in a tower while crystallizing into prills. For Stamicarbon, safety, health and environmental awareness is a precondition of innovation and a key condition for sustainable licensing. One example is the wastewater treatment section in Stamicarbon's plants, which produces clean water without a wastewater stream.
Another example is the ongoing development of processes for the production of enhanced release fertilizers and urea that needs less coating and has a better property for release of urea and nutrient, and therefore it is altogether much better for the environment.
Innovation is our lifeline to the future, really. We continuously pursue new technologies and new business ideas, and in order to employ a systematic approach for assessing these embryonic ideas, and as to get to the commercialization of the best ideas, we make use of the innovation pipeline methodology.
This efficient way of working has already led to a constant stream of innovations and registered patents. Stamicarbon's history shows that in a licensing business, survival and growth depend on three capabilities. First, its ability to strategize and adapt to the changing business environment. Secondly, its innovative drive to fulfill the requirements of its customers. And thirdly, its people's ability to work and collaborate with a network of partners, suppliers, and customers in developing and implementing new technologies.
Looking into the future, I am quite optimistic. The growth of urea as a fertilizer is slightly more than the GDP and the growth of the population. Currently, this means about 6 new plants that have to be built every year. And this ensures our new and future business. Next to this, we have started with the Myro-Technomon Innovation Center, which is developing new technologies to be licensed in the future. The combination of this with a very experienced, skilled and enthusiastic team of people that we have makes it that I have all the confidence in the future of Stamicarbon.